Testing 1, 2. Okay. All right, let's get started. This is OpenEdge TDE full database encryption. I've got a lot to get to, so I'm going to breeze through my intro. I'm Rob Fitzpatrick. I work for White Star Software on ProTop with Tom Bascom. We think you should use ProTop, so go see us in the booth. We have swag and t-shirts. And as you can tell, I'm not in marketing. So I'm talking about TDE. Why? There have been lots of talks over the years, and it's not new. So why another talk? Well, I tried to take a different tack with this, and it's just FYI not going to be a intro to TDE, TDE 101 type of talk, because I felt that was well covered in previous talks over the years, and also in the docs and the KB. So if you're not familiar with it at all and you're planning an implementation, you really need to read the documentation cover to cover. It's good, and you need to get through it. So the use case that I feel is becoming increasingly more valid is full database encryption. So I'm not going to spend any time on the agenda. We'll see these points as they come up. First, the scope. As I said, TDE is a big topic, and there's no way to cover all of it in an hour. So I am going to go through some of the mechanics just to establish a baseline of knowledge so we all have some understanding of how it works under the covers. And then I'm going to get to the sort of thesis of the talk, which is about encrypting your entire database. So I'm not going to go through some of the basics of setup and adding a storage area and that sort of thing. That's all in the docs. I'm not going to talk about which ciphers you should choose. That's your decision, and that can be a long conversation. So again, please read the documentation. Quick poll before we get started. Who here is using TDE in production currently? Okay, a few people. Are you planning a TDE deployment in the near future, let's say next year? Okay, good. Are you thinking about using TDE in the future? Okay, several people. How about none of the above? You're just here to show your boss you weren't at the bar the whole time? No? Tom, okay. All right. So let's answer the question, first of all, why? Because we can't talk about encrypting the whole database without having a valid business case for that. So perhaps counterintuitively, the purpose of using TDE is not to encrypt your data. That's what it does, but that's not why we do this. That's not an end unto itself. It's a means to an end. The purpose of doing this is because you are required by someone, maybe internally, maybe externally, to comply with some security regime and remain compliant and prove your compliance. So the end goal, the answer to the why question, is business risk mitigation. So when TDE first came out, which was in 2009 in version 10.2b, the original use case that was put forward, I think the motivation for the product was cases like healthcare data, payment card data, HIPAA, PCI, DSS, and other standards compliance regimes, customer data. That was what was deemed sensitive, and you wanted to encrypt that data at rest, that is on disk. And the original guidance from Progress was carefully pick the data that you consider most sensitive, encrypt only that and nothing else, because you want to minimize your performance impacts. However, this isn't 2009 anymore, and the security threat landscape has changed pretty dramatically over that time. We've seen the rise of ransomware as a service, network access brokers. These are people who don't care who you are or what you do or what your intellectual property is. They'll just hack you because they can hack you, right? They find out you're using version X firewall or version Y VPN software. There's a 0 day in that. They hack everybody who's got it, and then that access to your network becomes a saleable commodity on the dark web. So you can't hide in plain sight anymore. You can't say, I'm small, they won't get me, they'll go after the blue chip companies. Everybody's a target. Everybody's at risk. And your database could be exfiltrated and uploaded to the web. So if we think about a hypothetical example of that, let's say I have a 500 gigabyte database and I've carefully selected only the most secure data and encrypted that, the headlines aren't going to say, you know, Rob protected that really sensitive 100 gigabytes. The headline is going to say, Rob's company let 400 gigabytes of unencrypted database data get stolen. And at that point, you're not writing the headlines, you're not in control of the narrative, and you're in damage control mode with your clients. So the question I want you to ask yourself as you leave here is, am I still using an early 2000s security threat model in 2023 and beyond? Okay, deep breath. We're past the scary slides. Now we're into the fun, geeky stuff. So I'm going to talk a little bit about what TDE is, how it works under the covers, just so we've got kind of a baseline of knowledge. Okay, so first of all, from a licensing perspective, TDE is a product. It's an add-on product for the enterprise database specifically. So depending on your release, you've got some options. Tend to be in later, there's a TDE add-on product for the enterprise database. As of 11.5, there's a bundle called Advanced Edition Enterprise Database, which is the enterprise database plus all of the add-on products, including TDE. And in 12.6, a new product was added called OE Advanced Security. And there's a talk about that this week. So what is it? It's, as I mentioned, encryption at rest, symmetric encryption, so static keys. The data, when it's in memory, when it's in the buffer pool, is still unencrypted. So in that way, your applications don't know about the encryption, so it's transparent in that sense. You don't have to make any code changes to your application, whether it's ABL or SQL, they're still going to work. And the keys are stored in a new database file called the key store, that's dbname.ks in the database directory. The encryption is policy-based at the object level, and in the next slide I'll explain what I mean by object. These policies are stored in a new table called _secobj policy in the encryption policy area, which is an area you add to the database when you enable it. You're not allowed to read this table, so there are pro-util commands for that. And for each object, you can have a maximum of 2 policies, and they're called current and previous if there's a second one. And that permits you to rekey an object without having to decrypt it first. The unit of encryption is the database block. So an entire block gets encrypted except for the block header. So it's not file-based, it's not record or field-based. The single unit within an encrypted object is the block. The list of ciphers that you can use does vary by release. So if you're planning a deployment, check your release documentation. The default is AES 128. That's a good default. It's a good trade-off between security and performance, and you really shouldn't change that unless you have a compelling reason to do otherwise, like your security team tells you you have to. So what can you encrypt? Well, here's the list. Type 1 storage areas as a whole, objects that are in type 2 areas, so that is tables, indexes, or lobs, and that refers to the logical object as a whole, not a physical storage object. So for example, if you had table partitioning, you're not encrypting each partition individually, it's the entire table or the entire index. AI and BI encryption is enabled by default, although when that takes effect depends on how you implement, whether you do it online or offline. Your application data can also be in audit or CDC tables. You can encrypt those as well, although I'm not talking about that scenario today. And you can also optionally encrypt binary dump files. What you can't encrypt, well, the entire database in one shot, which is why I'm giving this talk. You can't encrypt type 2 storage areas, just the objects within them. You can't encrypt the control area or the schema area, but that's okay because you never have application data in your schema area, right? Just another good reason why you shouldn't. And if you do, you should be, table or index moving those out or doing a dump and load to get those out. You can't encrypt the encryption policy area for reasons that are hopefully obvious. You can't encrypt sequence values because they live in sequence blocks and they live in the schema area, but that's okay because really they're just numbers. They're not what I would consider sensitive data anyway. So when does encryption happen? It happens at the I/O level when blocks are read and written on disk. So if an encrypted block is read from a data extent into the buffer pool, that's when decryption happens. If a block in an object governed by an encryption policy is modified in the buffer pool and then it's later written out to disk, it's then encrypted under the current policy. So there's a clear performance implication here. Your buffer pool needs to be tuned well because the performance of your caching will determine how often you're going to pay that extra computational price of doing encryption or decryption. So if you can have more data memory resident and read and write less often, then your performance delta with using TDE will be less. And conversely, if you have poorly tuned application code, like you've got clients doing huge table scans or things like that and bringing lots and lots of data into the buffer pool, then that's going to hurt your performance. It's going to flush out other useful data, and so that's the kind of thing that you really want to avoid. So you might think I could just make a really big B and avoid this problem, but don't go crazy with it. Don't set such a big B that you're going to have other negative performance impacts, like you cause swapping in the OS, or you're extending your database shared memory across NUMA nodes. I'm not going to talk about NUMA today, but that's not something you want to do, as Tom demonstrated yesterday. So here's the pretty picture, at least as pretty as I can make it, of what I just said. So up top we've got, I can point. Up top we've got data in memory, and then we've got data on disk as well as the key store, which is on disk. So when an encrypted block is read from an extent into the buffer pool, it's decrypted, and when it's written, it's encrypted. So I'll just talk a little bit about the encryption cache. It's similar in concept to the OM cache, which you may be familiar with, the object mapping cache, which is a cache of the storage object records. So the encryption cache is a collection of data from both the key store and the policy table. And there are two caches, primary and secondary. Access to the secondary cache is always latched with the EC latch. And that's where any online changes, new policies get written. And it's sized with the EC size parameter. It defaults to 1,000, and that the unit is policies. So with the default, you can fit up to 1,000 policies in the primary cache. The primary gets populated at database start, and then 1,000 for the secondary as well. Don't be stingy with memory here. These are very small entries. It's not an exactly linear scale, but roughly for every one that you increase EC size, you're using another 215 bytes of shared memory. It's not a big deal. So my recommendation is calculate how many objects you want to encrypt. That is objects or areas. That's what I mean in this context by objects. Double that and make it a bit more. Because if you have policies for all of your objects and then you decide someday you need to rekey all your objects, well, that's creating that many new policies. Every time you change a key or you change a cipher, you're creating a new policy. The EC will expand if it needs to. It'll go up in increments of 1,000, but if it can't increase, if there isn't available excess shared memory, then the database will shut down. So that's why I say don't be stingy. You can increase it online, but only in 12.1 and later. And there's a screen in Promon, Shared Resources, which you may be familiar with. This is where we can see the OM cache as well. And at the bottom of the screen, we see the entries there for the EC primary and secondary. So when we encrypt data in a database, what actually gets encrypted? So this is a list of all of the block types and their block type numbers that you can find in a modern OpenEdge database. And so when we encrypt an object or an area, is it the entire thing that gets encrypted? No. It's actually just record and index blocks. So all of these other block types, there aren't as many of them typically as record or index blocks. But if you look at your ProStruct statistics or DB analysis, you might be surprised to find how many blocks there are in your database that aren't record or index blocks. So those are the only ones that are going to get encrypted in those objects. And even in a table or a lob, if you have record blocks that are completely unused, those will also not be encrypted. And that's just a performance optimization. There's no reason to encrypt them until they need to be because they have sensitive data in them. Just a quick word on Pro Backup. This is a screenshot of the documentation. Backup files are always encrypted. Not really. If you have data in objects that are not covered by an encryption policy, they're in plain text in the database, and they're going to be plain text in your Pro Backup file. In fairness to the documentation team, there is another place in the documents that makes a better description of this. It says, when you back up an encrypted database, the backup contains encrypted blocks. So again, whether it's in the database or in the backup file, the encryption is block-based, it's not file-based. Okay. So let's get to the TDE commands. As I mentioned, there are pro-util commands that you're going to use to work with TDE, and they all begin with this prefix. They're pro-util e-policy commands. There are 4 of them, and I'm going to go through what they are. So we've got pro-util e-policy manage, and then you can see the syntax there. There's a lot more to the syntax, as we'll see. But in general, it's object type, verb, object name, where object type is table, index, lob, or area. And this is for managing policies, both object policies and database policies. Next up is ePolicy scan, which deals with a single object, and it will tell you the status of the blocks in that object. So it'll give you counts of how many are encrypted under each policy, or if the object is encrypted at all. Next is ePolicy view, which again works with a single object, and it allows you to list the policy or policies for that object. And the last one I never use, it's just online documentation basically at the command line. It just gives you a list of ciphers that you can use, and they're cipher numbers because that's how you specify a cipher in the commands. So first up, ePolicy manage. On the next slide, I'll show you the syntax diagram. But so it's got a lot of verbs, a lot of different options that you can specify. The common ones are encrypt, which creates the initial policy on an object. Then you've got update, which will read all of the existing blocks in the object and encrypt those. You've got rekey, which will give you a new key with the same cipher as the existing policy. And then you've got the cipher verb, which will give you a new policy under a new cipher. So if you want to go from triple DES to AES 128, you would use that. Just a note, again, not too intuitive, the encrypt verb doesn't actually encrypt data. It creates a policy and it creates a key for use with that policy in the key store. And that determines what happens with future block writes on the object. Okay, it doesn't deal with your existing data. That's what the update verb is for. Again, here's pro-util ePolicy manage. This is actually You likely won't see it as being this complicated. This is from the 12.7 DLC, so you've got a lot of HSM-specific commands that have been added recently, but most of this you're going to see in your release. Just a quick note about encrypting type 1 areas. They have to be encrypted offline. But most of the rest of TDE you can implement online without downtime or very little. So next up is the pro-utility policy scan. Note that it reads every block in the object that you're scanning. So there's, if it's a very large object, you're going to have some I/O impact there. And it reports how many blocks are encrypted under each policy. So here's an example of a customer table. It's table number 4. It's got a current policy of AES 128, a previous policy of DES, and this tells you how many blocks there are and how many are encrypted under each cipher. It's the asterisk I put there because it's stretching the truth a little bit. As I said on an earlier slide, not all blocks get encrypted, but it's kind of fudging that, and it's making the numbers add up to every single block in the object, even though it's not actually doing that. Anyway, the ones that need to be encrypted are encrypted. That's the point. Next, we've got ePolicy view. This is, it doesn't look at the blocks in the object. It looks at the policies in the policy table for that object and tells you what they are. So it's a lightweight command because it's just reading 1 or 2 records. So here's an example of an object with 2 policies. Here's an example of an object that's not encrypted at all. And here's the ePolicy info. Literally all it does is write to standard out a list of the ciphers that are available in your release for the database master key and for object keys and also for binary dump keys. Although it's doing this and it's completely generic, it does require you to specify a database. I don't know why. Just a note here, the commands that I've shown you so far and the ones that we're going to see in the implementation section, I've simplified them a little bit. These are privileged commands. You have to be authorized to use them. And it depends on how you initially configured TDE, whether you're going to use a more locked down version of the command. There's an optional parameter on these commands, which is -passphrase. If you type the command interactively, just starting at pro-util and then end it with -passphrase, it'll prompt you at the command line to enter the TDE admin passphrase to prove that you're authorized to change encryption policies. That obviously becomes a problem when you're trying to implement at scale. You're not going to be, typing hundreds or thousands of commands at the command line. You're going to want to automate that with scripting. So what you can do is you can pass the passphrase through standard in to the command, for example, with a pipeline. So that could be catting a file, or that could be, if it's in a shell script, echoing the value of a variable. Neither of these, in my opinion, are a great solution because you're either exposing that sensitive passphrase in the file system or in a script and in the process list for that echo command. So I don't know of a better way to do this. Maybe there is one, and hopefully this will get better in the future. As Rob Straight mentioned yesterday, there's work on integrating with secrets management systems, and hopefully we'll see that in TDE. So now we'll talk about implementing TDE at scale. So here's what you need to do, or what I think you need to do, when you're encrypting one object. So you've got first a pro-util ePolicy manage encrypt command, so that creates the policy, doesn't encrypt any existing data. Then you've got ePolicy manage update, which does update all the data. So what it does really is it begins a process for scanning all the blocks in that object. So you can just trust that it's eventually going to finish, but that's, to me, kind of like starting a backup and trusting that it will finish. What you really want to do when you're doing a backup is check that you saw the command that said backup completed successfully. So the equivalent here is you're going to do an ePolicy scan at a later time and prove to yourself that you got this message that says X of X blocks encrypted. That's when you know, at least from a compliance perspective, that you're actually done. So it doesn't actually do anything. It's read-only. It doesn't do anything, to the blocks. But that's just how you prove to yourself that the update did actually do what you expected it to do. So if you've got 3 commands for one object and you've got, let's say, 1,000 objects you want to encrypt, you're not typing 3,000 commands at the command line. So even if you have, say, 20 or 50, it quickly becomes unwieldy and you're going to want to automate. So even if you are not considering doing full database encryption, these techniques that I'm going to talk about, they're still going to be applicable for you because you're going to have a similar sort of workflow. So I'm going to show some a very sort of simple hello world type of workflow. So I've got a set of programs and programs that create shell scripts, and those would be shell scripts that you would run, and those are going to produce outputs that you can then scan. I'll just note here that there are a couple of canned reports in the data dictionary for TDE. I consider them basically useless. Sorry, that's harsh, but it's true. Those reports, one of them is a detailed list. It gives you current and previous policies for each object. And the other one just gives you current policies. They both only tell you about objects that you've encrypted at the object level. It doesn't say anything about areas, type 1 areas that you've encrypted. And it also, importantly, doesn't tell you about the objects that you haven't encrypted. So if you want to encrypt everything, or if you have some curated list of objects that you're maintaining that you want to make sure they are encrypted, using those reports, you would have to carefully scan to see, is every one of the objects that I care about in that list? It's not going to give you a comprehensive list that you can just grab and look to see, am I where I need to be? So let's switch over to VS Code and take a look at that. Okay, so referring back to, oh, that would help if I would do that. Okay, so referring back to our list, I've got a program called list objects, and what I've done in that program, I'm not going to go through all the code, that's not terribly interesting, but I'll just describe what it does. List objects is going to make a list of all of the encryptable objects, that is all of the type 2 objects and all of the type 1 areas, and it's going to produce 2 text files. So it's going to produce a list of encryptable objects, which is, again, those objects that I mentioned, and also unencryptable objects, which are basically any tables, indexes, or lobs that are in your schema area. So it's going to tell you that you've got some remediation to do if you care about encrypting this data. That encryptable objects text file then will become input for some of the later programs. So there's one called create policies, and it's going to create a shell script that will emit pro-utility policy encrypt commands. We'll see that in a moment. Then you'll run that to generate the policies. And then next up, we've got a view policies program, which is going to emit pro-utility policy view commands in a shell script. You'll run that to get a list of objects and all of your objects and their policies, if any. And then in the last program, parse policies, That'll take as input the policy list and a cipher that you specify, and then compare your target cipher with the ciphers on each of those objects and tell you a little bit about their compliance status. This is not intended to be like, production grade code. It's basically sort of a hello world example to demonstrate for you what the workflow is for building your compliance process. Let's duplicate. Okay, hopefully you can read that. Text is a little small, but so first of all, the list of encryptable objects. This is literally just object type followed by object name. Let me just, see if I can make that text a little bit larger. How do you do this in VS Code? Let me just see if we can do this. How's that? That's a little better. Okay. Okay, so this is very simple. It's just, in this case, I'm running it on a sports database, and it's a slightly modified sports database, so I've got a little bit of variation in it. And in this case, I've got a couple of type 1 areas. I've got some tables, some indexes, some lobs, and these are all the ones that can be encrypted. And then there's also a report, I call this unencryptable objects, and it's a list of all of the objects that are in the schema area. So you would run this against your database and see, do I have some cleanup to do and get those objects out of the area so that they can be a target of a policy. And then after running the program that creates a shell script, in this case you're seeing it as a batch file, but the concept is the same. It's literally, the program is just going to produce this list of proutil commands that we saw earlier. These are proutil ePolicy manage encrypt commands, and it's what the program did was it consumed this text file, the encryptable objects, and produced this shell script, so that you're not doing all this manual typing. And again, if you had your database configured in a more secure manner, like with either a manual start on the key store or auto start user, then you would have to specify the passphrase when running these, because they are privileged commands. So once you create the policies, then there's the program that creates this shell script to view all the policies, and they all just get emitted into one file called policy list, and it looks like this jumble of stuff, which you don't want to be reading if you have thousands of objects. So I have a parser that turns it into something a little more appetizing. So this gives you the list of objects. You also pass in your target cipher, and so basically it's going to compare what is the current status of the object in terms of its policy or policies, and compared with the policy that you specified you want it to be on. So in this case, I ran it with AES 128. I said, that's my target policy. I want everything to be encrypted under that. And you can see the status. This is just me comparing your target to what it should be. So in the case of this second line item, it's encrypted with AES 128. There was no previous policy, so that's compliant from a policy perspective. Whereas, let's say this one at the bottom, it has a previous policy, which was DES, So the comment there is e-policy update required, meaning that that object could have some blocks that were encrypted under the current policy, so you're not technically compliant. And some others that just don't match, it says wrong cipher. This one here I'll note because that object is no longer encrypted. If you have an object that's encrypted, you can, to decrypt that one object, what you do is you issue another pre-util e-policy cipher command to change the policy to null. So that means from that point onward, any block writes won't be encrypted, but you could still have other blocks that are encrypted under the previous policy. So that's as much of the workflow as exists right now. I have code for this, and I'll give you my email address at the end if you want to look at this sample code. An important thing to note, though, is that what we're looking at here is just policies on the table, and it's not telling you about the status of the actual blocks. If you have, if you want to ensure full compliance, and you don't have all of your blocks encrypted, or you have two different policies, then you're going to want to do the pro-util e-policy update. I haven't automated that because you need to bear in mind the I/O cost of that potentially. If you've got a 1 terabyte table and you're going to go through and encrypt all of that, that's a lot of I/O, and that could disrupt your OLTP operations, so you'd probably want to schedule that at an off time. You don't necessarily want to write one shell script that's going to blast out, you know, e-policy update commands for every table and index. So that's something that your particular use case is going to determine how you're going to implement that operationally. Okay, let's get back to the slides. Any questions about that so far? Okay. So, just a few more thoughts about TDE. I mentioned that it was released in 2009 in version 10.2b, and so you might wonder, is this 2009 era technology? Did Progress ship it and forget about it? No. This is a selected list, not a complete list of changes that were made to TDE over the years. I'm not going to go through each one, but what I'm demonstrating here is that Progress does continue to invest in this product. It's clearly strategically important for the company, and I'd say more so now than ever. I will call out one thing, which I think is even more important than all the features that they've added, is the features that they've taken away. In 12.0, Progress removed the RC4 cipher because it's no longer secure, as well as the DES cipher for binary dumps. So what that tells me is that they're continuing to evaluate the real security value that the product provides, and that's just essential for any such product. So that gives me peace of mind that I can use it confidently and know that my data is going to be secure, and you should feel that way too. Tom has a question.
So when Progress removes a cipher, what happens to data that was already encrypted with that cipher? Are you forced to change to a new cipher? Do you lose the data entirely? How does that work?
So the question for the recording is, what happens when Progress removes a cipher? Do you lose access to the data? I'm going to go ahead and say no on that. I believe what that would mean is that you're no longer able to create new policies under that cipher. So when you're specifying the ePolicy encrypt command, you won't be able to create, that policy simply won't be, that cipher won't be in the cipher list. You won't be able to create new ones. That said, I haven't tested that, so I don't know, but I can't imagine Progress just saying, nope, no more data for you. Good question, though. I didn't think of that. Yeah, so that's, yes.
So does it change the size on disk? You know, because you obviously organize your data based on the size of your records, right? So when you encrypt it, is the encrypted data exactly the same size so your blocks aren't
Okay.
changing your records for blocks per cluster, that kind of?
Yeah, so I probably should have diagrammed what it actually looks like on disk. The question is, does encryption change the size of your records? And a block is still a block, right? If you have an 8K database, every block is 8192 bytes. So when you encrypt a block, let's say it's a record block in a table, the entire data payload of the block, that is everything below the block header, gets encrypted. So there's no longer any structure in that data. So if you were to look at an unencrypted block, there's structure there. So you've got a block header, an RM header, a row directory, empty space, then record fragments, and those record fragments have a structure to them as well. They've got metadata and field values and field lengths and so on. None of that structure is visible because the data is encrypted, right? It removes any patterns in your data. That's what encryption is essentially. But it's not like one block's worth of record fragments is going to get stretched out into 2 blocks and then push things over, and all the DB keys remain the same, all the row IDs remain the same. So it's not logically transforming the data in any way.
And it's not physically changing the size so that it creates an issue on disk.
It's not physically changing the size of the data, so it's one for one in that sense. Although when we use, let's say, -com with ProBackup, right? That's right now that's a run length encoding algorithm, so it squashes any empty space, whether it's in empty blocks or in record blocks because they have some free space in them, or index blocks. When you have an encrypted block, it's all just pseudo-random noise, right? There is no pattern, there is no big contiguous chunk of empty bytes. So well-encrypted data is, theoretically uncompressible. So you're probably going to see that impact operationally in terms of your backups being larger than they were before you encrypted. But I can't really give you a percentage on how much that is because, again, it depends so much on the implementation details, how many policies you have, how much data you have, how you've structured your areas, and so forth. Yeah. Okay. So, one more scary slide. This is industry standard symmetric crypto, and as with any symmetric encryption product, all of the security is in the keys, and the keys are stored in the key store in this case. So, and access to the key store is protected with the passphrase. So they are the keys to your kingdom. Do not lose them. If you lose them, do not call Tom. He won't answer the phone. Don't call Progress. They can't help you. Your data's gone. So you need to be protecting that file. You need to be backing up your key store when you back up your database. So from a business continuity perspective, that is even more important than your data. You can lose some data, and still have the rest of your data, but if you lose your keys, your data's gone, in effect. And again, I'll say it once more, read all of the documentation before you deploy. All of it. Paul has a question.
Can you conv 1112 encrypted database?
Can you conv 1112 an encrypted database? I don't see why not.
The reason I ask is you restore a backup. Someone asks you to restore a backup from 6 years ago, and you've got to do like a conv 10, 11, 11, 12, 12, 13. You've got a key store, and I'm just wondering if
Yeah, I mean,
potentially problematic.
conv 1011 or other similar conversion utilities across a major version boundary are bringing your schema area up to date. primarily. So I can't give you a definitive yes because I haven't tested that, so I don't want to tell you something I don't know definitively. However, if you had to fully decrypt all of your data in order to cross a major version boundary, that would really defeat the entire purpose of the application. Yes?
Confirmed you can, but then you must also remember, just to be clear, when you're enabling it, enable an admin and a user. So anything that needs to be, for example, common antenna or whatever, needs to be run with the admin user. So now we're also just bring into for example, replication. Happens now, but what we're talking about target. Well, yes, we've got that as well. If you're going to fail over and fail back, as admin.
Okay.
As user, you know, any database operation as admin.
Right.
Otherwise, it will fail.
Okay.
And then you.
Thank you for the clarification. So yes, you can convert a database, but you have authorization restrictions when you're using TDE. Sorry, yes.
One short question, long. So the short question is, do you know the type of that key store Progress is using? Because why I'm raising that question, the PCI DSS comes with some strict requirements, also requirements covers those key stores. So I cannot list now those possibly three possible types of key store exist. And the third, the last one is to use HSM. So HSM, as you understand, means additional money, additional infrastructure, everything. So, but I never found in progress documentation over the type of key store. That key store is non-standard for sure. I tried to open with
Yeah.
Explorer or something. But
Yeah, so the question is, what is the structure or the format of the TDE key store? I've asked about it in the past. I was told we're not going to tell you. So it's proprietary and purposely undocumented. As you note, though, in 12.6, Progress added an enhancement for using an HSM, my understanding is, as a second factor of authentication for the key store. So I really don't know any more about the feature than that Progress has implemented HSM integration. So as I said earlier, I expect to see further changes in terms of integration of, sort of a centralized secrets management, and maybe that can come into play with TDE. Rob talked about that in his roadmap talk, about using that secrets management system for a centralized repository for CA certs and passwords and any secret data. So I would think that TDE database master keys and object keys would be a natural fit for that as well. But that's obviously a future thing. So I don't have an answer for your question, in terms of compliance with, say, PCI DSS key store requirements.
the second question, sorry for that, but can you explain a bit how the rekey process looks like? So how it physically looks like, it supports the two sets, new and old, and
Okay.
how it looks physically, just for new.
How it looks physically.
Yes, when we have bunch of data already encrypted with some kind of keys,
Yes.
with some cipher, then we, for example, the real example, we taking data from production and have to move to test environment. So we will take the data, but we cannot use the same key store for test environment. We have to rekey.
Okay, so the question is, can I explain the rekey process? And there was also a follow-up question about populating a downstream environment like dev or test from prod. So rekey is when you have an object that has one policy, a current policy. So let's say it's AES 128, okay? So that's the cipher that is an attribute of that policy for that object. So the object type, the object name, and the cipher, and a key identifier are attributes of the policy, okay? So when you rekey, you're not changing that policy. What you're doing is you're creating a new policy. So any block rights for that object after that command has been entered will be under the new current policy. Right, so the old current policy becomes the previous policy. The new policy is now the current policy, and it's got a new key, okay? And so any new block rights, any future block rights on that object will be governed under the new policy. Any existing data that was already on disk, it's still encrypted under what is now the previous policy. So every block is encrypted separately, so their encryption state is tied to one of the two policies, okay? So when you talked about getting data out of prod and into somewhere else, it's really good, and the mechanics of it depend on how you do that. If you're doing backup and restore, then you can back it up, make that your test database, copy over your key store, and open the database, and you're there. If you're going to do something like a dump and load to get your data over, then you can, as I said, if you're doing binary dumps, you can encrypt those. You would just load them in as you would normally, but you're going to specify a password when you do the load. If you're doing unencrypted dumps, then you're into, let's say, an encrypted test database, then it's just going to be a normal load.
Okay, the good practice is, anyway, in this environment, we want to have some kind of encryption, just to impact the testing process, to know how it impacts the database load or something. So, but possibly it is not a good practice just to use the same keys. So data should be unencrypted, not decrypted, and then fully encrypted with new.
Yeah, so the comment is best practices in key management say that you don't reuse keys for different purposes or in different environments. So you could have an encrypted test database completely separate from prod, different keys and everything else, and do it that way. The other way that I think is more practical is just simply take a backup of prod, restore it as test, and then rekey your objects. And then at that point you have all new keys, right? And once you are automating that, it's not going to be a big deal. You're just going to run a command, rekey all your objects, and now all of the keys that were in prod are no longer in your test key store. Does that make sense?
Yeah, but after keying those, anyway, they will remain
In the test environment.
What about just changing the password?
Changing passphrases? You can change the passphrase, and the passphrase, governs access to the key store, but the underlying keys are still going to be the same, I believe. Unless someone can contradict me on that, Tom. Oh, Tom is saying 5 minutes. Okay. You had a question?
Yes, the good practice in your first slide, you mentioned that everything should be encrypted, and you've done so. Is that right?
Everything should be encrypted? Did I say that?
No, but you mentioned that if something is not encrypted, it's not a good idea.
Well,
Papers and so on.
okay, so
Recommendation.
at the end of the day, what we're talking about here is mitigating business risk and encrypting our data and proving to ourselves or our auditors or our regulator, whoever, that we've done that and that we've done it correctly and that we have a process for continuing to do it. Sorry, I lost my train of thought. Okay, encrypting everything or not is a business decision, right? It's not something the DBA is going to decide. It's really something the application owner has to figure out. What is my business risk? What is the value of my data? What is the cost of the exposure of that data? the cost to my organization, reputationally, with customers, etc. So I can't tell you you should encrypt everything. I'm saying that I think that there are cases that are valid where it's prudent to do it if you can.
Because in previous documentation, it was always said that it was not recommended to
Yes,
encrypt everything.
it was recommended don't do everything because,
Maybe today is a little bit different.
yeah, I mean, I'm not telling you that it's a panacea. It's not a fix-all, and it's certainly not free. Encryption is work, and work isn't free. It has a computational cost. It's going to make some things slower, and it may make things a lot slower. You're going to have to test that, though, with your OpenEdge release, with your data, with your application on your hardware, and see what that cost is. And that the feasibility and the outcome of that will be one of the inputs into that business decision about should I do this or should I not, or how much should I do. Right? I can't give you an answer on that. Do have a few slides left. How are we doing for time? 4 minutes. So my take on TDE. It's a great product, and if you require encryption at rest in an OpenEdge database, there is no alternative. You should be using TDE. You definitely should not be trying to roll your own encryption or try to encrypt individual records and store the keys somewhere. That's the road to hell. Don't do it. That said, TDE is not perfect. I think it could benefit from some usability enhancements. And as I said at the outset, you're not using TDE to encrypt your data. That's not the end goal here. You're using it so that you can get compliant and remain compliant with some security regime. And so on the encryption side, they've nailed that. It works, it's robust, it's totally reliable. I'm fine with that, but it needs, I think, scalability improvements. Yeah, I think I've made my point there. So I think I've covered that. This is important. Applications evolve. You're not doing this as a one-time implementation and saying, okay, I'm done. I've done TDE. No more to do. Applications evolve. That means schemas evolve. So if new tables and indexes get added, or even if new fields get added to an existing table, that can change your compliance stance. Imagine you have a customer table and that's not sensitive to you, and then the vendor adds a credit card field. Oops. Now I have a PCI DSS compliance requirement on that table that I didn't have before. So even something as seemingly innocuous as changing a field or changing an index definition can require changes in your TDE. So you need to have a workflow where you're going to, as an ongoing process, look at the changes that have been made in your schema, in your application. You're going to assess them based on your security requirements. You're going to create your policies. You're going to encrypt your existing data, if any. And then you're going to report on all of your objects, all of your block counts under each of the policies, and prove to yourself, and therefore be able to prove to someone else at a moment's notice, yes, I'm compliant, and here's the proof that I am. You don't want to be tap dancing when the auditor shows up. You want to have a process you can just run and say, here's your report, I'm good. So, encryption is not a security solution in and of itself. It's a necessary condition, but not a sufficient condition for security. You need to have policies that articulate in writing what you plan to do, what you consider secure, what you want to encrypt. You need to have procedures that are robust and well tested that implement those policies. And most importantly, you need people who are educated and trained in what those policies are, how to run those procedures, and why their role in that process is important, and why they should adhere to those policies and procedures. If you don't have that, you're eventually going to run out of compliance. That's just human nature. So there is actually functioning code. You didn't really see it in this presentation, but if you want it, please send me an email and I'll send it off to you, and that's my time.